Hello and welcome to the Sleepy Physicist. I'm so glad you found your way here tonight. Whether you're lying in the darkness, nestled in cozy blankets, or simply letting your tired mind and heavy eyelids relax, this little part of the cosmos is specifically designed for you. Tonight, we'll embark on a gentle journey into something unseen but profoundly strange, a central mystery of how the universe unfolds. We'll softly step into the moment before things become real, that quiet space just before a choice is made, before a particle emerges, before the world reveals itself. Now, a word of caution. I've tried to make this as soothing and sleep-friendly as possible, but these ideas might still spark your curiosity. If they do, and you find yourself awake a little longer than planned, I hope that curiosity is a comforting one, the kind that allows you to drift off feeling a bit wiser than you were when you arrived. If you find this space to be peaceful, I would be very grateful if you would gently like the video or tap subscribe for more relaxing science stories like this one. And if you wish to leave a subtle mark on the universe in return, there's a super thanks button and even an option to become a channel member. Every small ripple of support helps this sleepy journey continue. So, take a deep breath. Release it slowly. Let your thoughts become loose and weightless. Tonight, we are entering the quiet, into a space the universe only enters when you do. Imagine a room with no walls, no floor, and no ceiling, a place that doesn't exist yet but quietly awaits your presence. This is where our story begins, in the stillness before something becomes something. Here, the universe isn't yet made of particles, light, or matter. Instead, it is made of possibilities, unfinished drafts, and half-formed choices. This isn't because something is missing, but because nothing has been asked of it yet. You haven't looked, so the world hasn't decided. This isn't just poetry, it's physics, specifically quantum physics. This field is so subtle and delicate that it behaves as if the very act of noticing something changes what is being noticed, and in many cases it does. In the quiet before observation, particles don't behave like the solid objects you're familiar with. They aren't fixed or located in one specific place. They float in a dreamlike superposition, a term scientists use to describe being in many places at once, until you look. It's like a thought that hasn't been spoken yet, or an unopened book on a table. It could be any story, but once you choose a page, that story begins, and the others fade away. You are lying still in bed now, but your mind wanders gently, and that wandering may not be so different from what reality itself does when it is unobserved. The quantum world doesn't rush to form conclusions. It rests in a state of openness, waiting for the gentle pressure of curiosity to give it shape. Imagine a particle as a tiny idea floating in darkness. It doesn't settle into a single path until someone or something checks on it. Until then, it holds many paths within it, like a dream containing every possible ending at once. What causes this dream to become something real? That is the question physicists have contemplated for over a century. In the early 20th century, a group of thinkers began to suspect that the act of measurement, of simply looking, might play a role in shaping outcomes. They suggested that particles, in a strange way, don't become definite until someone watches. This doesn't mean that human eyes create the universe, but it does suggest that interaction is important. It implies that the world isn't a cold, independent machine, but something softer and more responsive, like a canvas waiting for the lightest brush stroke. So you see, the quiet room before observation isn't empty, it's full. It's full of uncertainty, yes, but also full of potential, like clouds that haven't yet decided whether they will release rain. This room exists in every atom, every flicker of light, every moment before a decision is made. You can't enter it with your body, but your thoughts constantly wander there. Take a moment to imagine being in such a space, not knowing, not deciding, just being. The clocks haven't started ticking. The page hasn't been turned. The universe is holding its breath. And then, with a whisper, something shifts. A glance, a question, a moment of focus, and the wave of possibilities collapses into one. This is the quiet magic of observation. It's not loud or dramatic, just a soft collapse, a subtle folding in, as if reality gently chooses when asked. You might think, is it really that simple? Just looking. Well, not quite. The truth is more nuanced, wrapped in equations, probabilities, and complex interpretations. But even the deepest science still returns to this curious fact. The outcome of a quantum event depends in an essential way on how it is measured. And that brings us back to you. Because whether you're watching the stars or simply letting your thoughts drift into darkness, you are participating in a universe that, in its smallest parts, may be waiting for your attention. You don't need to understand every formula or theory to feel this. The intimacy of being in a world that responds not randomly, but relationally. It's not that you create reality from nothing, it's that your gaze, like gravity or time, shapes what is possible. And in that shaping, you are not alone. Every particle, every photon, every trembling atom, they are all part of the dance. So rest now in the stillness before the world decides. Float in the space between, maybe, and yes, between silence and sound. This is the room before observation. The door is still closed. But what happens when you open it? When you ask the universe a question? In the next chapter, we'll follow a beam of light through a quiet experiment that changed everything. A pair of tiny slits and a mystery that still echoes through science today. The double-slit experiment. On a table, there's a screen. In front of the screen, a barrier with two narrow slits, just wide enough for something as small as a quantum particle to pass through. This simple setup, known as the double-slit experiment, may seem unassuming, but don't be fooled. Within this arrangement lies one of the most profound puzzles in all of physics. Tonight, your mind will gently explore this puzzle, not to solve it, as it has baffled the sharpest minds for over a century, but to feel its strange rhythm, to listen for what it might be whispering in the gaps of certainty. Now imagine you are observing a stream of particles. They're small, perhaps electrons or photons, those tiny bundles of light. You send them one at a time toward the barrier with the two slits. You expect a clean, neat outcome: a dot here, a dot there, a tidy pair of marks behind the slits, as if each particle had chosen a path and passed through. But something else happens. What appears on the screen behind the slits isn't two dots but a pattern, a wide, delicate ripple of light and dark bands stretching out like a probability fingerprint. This is called an interference pattern, and it shouldn't be there if the particles are behaving like tiny, solid marbles. Interference is what waves do. It's what happens when two ripples on a pond cross paths, amplifying, canceling, and curling into new shapes. It's the music of possibilities overlapping and unfolding. So, if each particle were just a particle, a solid dot in space, it would land behind one slit or the other, creating two distinct clusters. But instead, what you see is the whisper of a wave, as if each particle passed through both slits at once, interfered with itself, and landed somewhere guided by that interference. But how can one thing travel two paths at the same time? It is here that the quantum world begins to shimmer. In this subtle domain, particles don't always behave like solid objects. They behave like possibilities, like echoes of where they could be. Each particle is a wave of chance, and the double-slit experiment reveals just how strange that chance can be. But then, you decide to take a closer look. You place a detector at the slits just to see which one the particle chooses. A harmless question. You think, simple observation. And everything changes. The wave pattern disappears. The interference is gone. Now the screen shows two solid clusters, exactly what you'd expect if the particles had behaved like tiny marbles all along. It's as if by asking the particle which path it took, you forced it to choose. The act of watching collapses the mystery. The particle no longer entertains both possibilities, it becomes definite. The whisper becomes a footstep, the wave becomes a dot. This is what captivates physicists, poets, and dreamers. That your act of looking, your curiosity, doesn't just reveal reality, it seems to shape it. Not because you are special, but because in the quantum world, observation isn't passive. It's an interaction. It's a touch. Even the gentlest glance ripples through the system. This doesn't mean your thoughts control the universe, but it does suggest something gentler. That the universe is not a fixed thing waiting to be unwrapped. It's a flowing possibility, meeting you halfway. And so, you sit by this quiet experiment, this table of slits and light, and you listen. You imagine the wave passing through both slits like a soft breath slipping between curtains. You see it spread across the screen in a silent rhythm, forming peaks and valleys of probability, a dance of chance and structure, a pattern not of particles but of questions. That is, until the moment you ask, which way did it go, and the wave collapses. The mystery tightens into one answer, not because it had to, but because you touched it with your attention. In this way, the universe seems to echo your curiosity, not as a mirror but as a partner. It holds its form loosely until something or someone gives it a reason to decide. And this pattern repeats again and again. Even when the particles are sent one at a time, the interference still builds up, unless you watch them. Then, each behaves as though it always knew you were looking. It's not about deception, it's about possibility. The particles aren't hiding, they are waiting. Not for permission, but for context, just like thoughts before they are spoken or paths before you choose which one to walk. So tonight, as you rest, You can think of yourself not as a separate observer peering into a cold machine, but as part of the process, a participant in the great unfolding of what is real. When you don't look, the universe plays like a wave. When you do, it becomes a story, one that starts where your attention begins. This wave-particle duality isn't a flaw, it's a quiet feature of the quantum world, one that defies certainty but invites wonder. You don't need to resolve it to feel its beauty, you only need to listen. And perhaps that is the secret, that reality waits for your question, not to answer, but to become the kind of thing that can be answered. As the slits fade and the light rests, you are left with a gentle tension, a memory of both paths and the mystery of having to choose. But what if the particle isn't alone? What if somewhere else, another particle is entangled with it? And no matter how far apart they drift, they remain connected, like two notes from the same chord. In the next chapter, we'll follow that thread across space, across silence, to where connection defies distance, and two particles respond as one. The observer effect and quantum entanglement. You have been watching gently from a distance, like a dreamer observing ripples in a pond. Light bending, particles dancing, probabilities painting soft patterns across darkened screens. But tonight, something shifts. Tonight you step into the story, not because the stage was waiting for you, but because it seems the stage never quite appears without you. The spotlight, the scenery, even the music of the particles, they all seem to lean in when you do. And so you wonder, are you simply watching the universe, or are you part of the reason it unfolds the way it does? This idea is not mystical, it's mathematical, embedded in the rules of quantum physics. There lies a strange suggestion. The observer is not separate from the observed. Your act of measurement, of looking, listening, asking, is woven into the very fabric of how reality becomes what it is. The particles don't simply exist, waiting to be found like marbles on a floor. They emerge through interaction, like echoes meeting walls that weren't quite there before you spoke. This is not how the classical world works, not the world of falling apples or spinning wheels. In that realm, observation is safe and distant. You can look without consequence, the apple falls whether or not you're watching. But the quantum world is more sensitive, more subtle. Here, your attention matters. It doesn't control things like a switch, but it participates, like breath joining the air. You begin to sense that reality is not something you stand outside of. You're within it, always a part of the equation, even when you're still. Let's take a step deeper. In quantum mechanics, the idea of measurement isn't limited to human observation. It can be any interaction that draws a particle into a relationship with something else. A detector, a surface, even another particle. But measurement in this world is never neutral. It collapses the cloud of probabilities into a point. A wave becomes a fact. A field becomes a spark. All because something, anything, said, "Here, now." And that's where you come in. As a conscious being, you don't just detect, you reflect. You ask questions. You name the patterns. And even if you don't collapse the wave yourself, your curiosity plays a role in what gets measured, what gets studied, what gets noticed. In this sense, you are not merely an observer, you are a participant in the unfolding narrative of nature. Not the author, perhaps, but a co-reader, a co-translator, a quiet hand on the page. This perspective is both humbling and exhilarating. You're not outside the experiment, you're inside it. The observer effect means that your involvement isn't a flaw in the data but a feature of the system. You matter, not because you dominate, but because your presence, even your potential to know, shapes what's real. This idea was unsettling even to the scientists who discovered it. Einstein, Bohr, Heisenberg, they all wrestled with the implications. Could reality truly be so dependent on perception? Could the moon exist without being looked at? Of course, we believe it does. The world carries on without our gaze. But at the quantum level, where reality is soft and shifting, the moon, or at least its tiniest parts, may not be so certain until they are asked to show themselves. And so, a strange image arises, a universe that responds not just to being but to being noticed. Not because it needs approval, but because it is, at its core, relational. You exist in that relationship. You, with your quiet thoughts and gentle breath, belong in this dance of noticing and becoming. You are not just witnessing the world's story, you are shaping the questions that define it. Your awareness isn't a spotlight shining on a fixed scene. It's more like a tone, a frequency that resonates with the world around you. Wherever you bring your attention, something shivers into clarity. And this might change the way you think about yourself. Not as a mind floating above matter, but as matter infused with mind, tuned to respond, to explore, to ask. Even in sleep, your brain hums with patterns that reflect the same strange logic as the quantum world. superpositions of thought, entangled emotions, possibilities collapsing into dreams. You are, in some small and beautiful way, a reflection of the universe you're observing. And the universe, perhaps, is a reflection of your capacity to observe. This is not a call to believe you control everything. It is, instead, an invitation to realize that you are involved, that your presence matters, that reality in its softest places waits for someone or something to join the story. And when you do, the story shifts, just like the particle chooses a path when watched. The world may unfold in new ways through the questions you bring, the quiet hopes you carry, the wonder you feel even now. And that wonder grows. Because if a single glance can change the outcome of an experiment, what happens when particles are linked? What if one particle responds to your measurement by affecting another far away? What if, in this quiet, unfolding story, there are threads that remain tugged, no matter how much distance lies between them? In the next chapter, we'll follow one of those threads into the mystery of quantum entanglement, a connection that defies space and perhaps time. A gentle bond that whispers, you are never truly alone in the story. A quantum state's an entanglement. What is a thing when it isn't quite a thing yet? What is a choice before it's made? Tonight, you'll drift into the strange space between knowing and not knowing, the space that quantum physicists call a state. But don't let the word fool you. A quantum state isn't a location, not an object, not even a snapshot in time. It's more like a whisper of what could be, a deep stillness where the future has not yet taken form. And right now, as you lie back and breathe slowly, you're already closer to it than you think. A quantum state describes the condition of a particle or a group of particles in its full potential and rich ambiguity. It's not a simple statement like, the particle is here, or the particle is spinning this way. It's softer than that, more layered. It's a quiet superposition. A set of all the possibilities the particle might embody, gently coexisting like morning mist that hasn't yet lifted. It doesn't insist, it doesn't declare, it simply allows. You can think of it as a song not yet played, but written into the strings of an instrument. The potential is real, the notes are there, but the sound only arises when someone plucks a string, when the instrument meets the world. In the same way, a quantum state contains all the possible realities a particle might show you. If you were to look at an electron, for instance, you might wonder where it is or how it's spinning. But until that moment of measurement, the electron isn't tucked away, hiding the definite answer. It exists in a quantum state, a blur of probabilities. It isn't indecisive exactly, it's inclusive. It holds every permitted outcome at once. And then, as we've seen, a gentle measurement collapses that soft web of options into one actual result. The state condenses. The wave becomes a point. This is the heart of quantum mechanics, not uncertainty in the sense of chaos, but uncertainty as a kind of promise. The universe isn't bound by single possibilities. It prepares a spread of paths and lets the context, the interaction, reveal which path is walked. And still, this word state, it might sound too technical, too clean. But try thinking of it another way. A quantum state is like a seed containing the blueprint of a tree not yet grown. The tree might grow tall or crooked. Its leaves might be sparse or full. The soil, the light, the winds of chance all help determine which version of the tree unfolds. But within the seed, every shape is quietly possible. You're surrounded by these seeds. Every particle, every quantum field, every atom in your body. They all move through existence as part of a quantum state. Even your thoughts arise from chemical exchanges that, at their base, dance with quantum uncertainty. You are built from possibility, but not chaotic possibility. These are patterned, structured possibilities shaped by the quiet mathematics of wave functions. Each state has its own logic, its own rhythm, its own rules for how the world might evolve from it. And these wave functions, though invisible, are incredibly precise. They describe how likely a particle is to be here or there, to spin left or right, to appear when asked. The closer scientists look, the more accurate these predictions become, not because the state is deterministic, but because the probabilities themselves are part of nature's design. It's a strange comfort that the universe doesn't always need to know in order to work beautifully. And neither do you. You don't always need to collapse the wave to pin things down. Sometimes it's enough to rest within the state, to allow the options to float, to feel the quiet in-betweenness of potential. Just like tonight, when sleep hasn't come yet, but wakefulness has faded. That's a kind of quantum moment too, a space where your thoughts still roam freely, where memories blend with dreams, where the story hasn't chosen a direction, but every direction is softly lit. There's another layer to this too. Quantum states aren't always solitary. Sometimes multiple particles share a state. They become entangled, their possibilities intertwined. We'll explore this more deeply soon, but for now, just know that when particles become entangled, their quantum states can't be separated. One changes, and the other responds even if they are light years apart. So a quantum state isn't always about one thing. It can be a bond, a relationship, a chorus of outcomes waiting to be sung. And your role: you don't conduct the music, but you do hold the sheet. You participate by listening, by asking, by simply being aware. And that awareness, it doesn't collapse the universe, but it does gently bring parts of it into form. In the end, a quantum state is a place of trust. The universe trusts you with its uncertainties. It hands you a field of shimmering possibilities and lets you walk through them one step at a time. You don't have to understand the equations. Just feel the invitation to slow down, to notice the soft boundaries between what is and what could be, to rest in the space before things are named. And maybe, just maybe, to see yourself not as a fixed being, but as someone always unfolding, like a particle in motion, guided by a wave you can't quite see. So breathe softly now. Let your mind loosen its grip on certainty. You're already part of this field of possibilities. You've always been. And as you drift into sleep, know this: you are not alone in this state, because somewhere in the quiet edges of space, there may be another particle, one whose state is woven with yours, whose fate dances with yours, no matter the distance. In the next chapter, we'll follow that connection into the heart of quantum entanglement, where two become one and separation becomes a question, not a truth. The love story of entanglement. There is a kind of love story hidden deep in the fabric of physics. Not romantic, not emotional, but profoundly intimate all the same. It's the story of entanglement, of particles that once touched and then carried each other's imprint forever. Tonight, you'll follow their thread. A quiet, invisible thread that stretches across space unbroken. A whisper across the universe, shared by two tiny dancers who will never forget they once moved as one. Start by imagining two particles born from the same event. Maybe they emerged from a single reaction, like twins from the same spark. Their properties are linked, not just in the past but in the present and future. If one spins left, the other must spin right. If one reveals its state, the other's state clicks into place instantly. You take one particle and drift far away with it, light years away if you like. You keep it safe in a quiet lab, resting in stillness, and then you measure the other. In that moment, the moment you ask, your distant particle's state becomes known. Not because a message traveled between them, not because anything moved faster than light, but because somehow the link was never broken. Einstein called this spooky action at a distance. He didn't like it. It seemed to violate the rules of space and time, as though the universe was playing tricks. How could two things so far apart remain so deeply in sync? But the experiments have been repeated again and again, and the results are clear. Entangled particles behave like parts of a shared reality, no matter how far they roam. It's not that one particle sends a signal to the other, it's that they were never separate to begin with, not in the quantum sense. Their states are part of a shared equation, and when you solve one half, the other half responds instantly, like the other side of a mirror. It doesn't mean they think. It doesn't mean they feel. But it does mean that the world, at its softest level, is connected in ways we can barely imagine. And so you lie back and think of all the separations in your life, all the distances, the silences, the empty space between people, places, and moments. And you wonder, what if distance isn't always what it seems? What if connection runs deeper than touch, sight, or even time? Entanglement doesn't let us send messages faster than light. It doesn't break causality. But it does tell us something else, that reality may be relational before it is spatial. The relationships are not just the result of proximity. They're a fundamental feature of how things exist. The entangled particles don't carry hidden messages. They don't carry secret instructions. They simply are what they are, parts of a single whole, no matter how wide the gap between them. You might think of it like this: when you twist one side of a ribbon, the other side twists too. Not because anything traveled from one side to the other, but because they are one thing. Or imagine a melody played in two locations at once. You hear one note here and another note far away, but together they form a single song. That's what entanglement sounds like, not a signal, but a harmony. And you, as a conscious being tuned into the world, can feel that harmony even if you don't hear it. You're made of particles that were once part of stars. Your body holds atoms that danced near each other in the early universe. Who knows what entanglements you still carry, quietly woven through you? Some scientists have even begun to wonder whether entanglement plays a role in biology, in the strange precision of enzymes, or the way birds navigate by sensing magnetic fields. These are open questions, but they hint at something intriguing: that entanglement isn't just a trick of tiny particles. It may be a thread running through the living world. 2. It is not just physics. It is pattern, connection, and memory written into matter. And the more you reflect on it, the more you realize this isn't a story of control. It's a story of belonging.